Hi, all. Welcome to another session on statistics for data science. And in the last session, we've seen the descriptive statistics. So now we are going to analyze one by one the measures that are related to descriptive statistics. The first one is the measures of central tendency. What is a central tendency? So let's say you are dealing with 50,000 rows, and as you know that we cannot concentrate on each and every single row. Okay, so but then we have to represent something. Okay, some value has to be there to represent your 50,000 rows. So that is called a measure of central tendency. Okay, that one value will tell the whole picture. Okay, so everything about you will get an idea about your entire data. See, for an example, average age of country India. So let's say we've got so many people living here, but then that one value, the average age of country India is, let's say for an example, 30. So it will you will understand that with that one value, we will understand that, see, India is having youth. So that is the central tendency. So one value which will give the picture of your entire data. So we've got three measures: mean, median, mode. So what is mean? So mean is a very simple one, like how we have learned in our school days. It's nothing but your mean represents what? It is the total value of all the points. You add all the data points divided by number of observation. Okay, so let's say 2, 4, and 6. So you add all the points. Let's 12 divided by 3. Okay, so you're gonna get the average. So this is your mean. Okay, simple mean. And it works best when the data is evenly distributed. This is very, very important. See, what is evenly distributed data sets? So let's say you are dealing with A grade students. Okay, so A grade means the students who have got above 80, and their maximum marks would be, let's say, 99 or 100, but they are in the same category. Okay, their marks, their number of hours that they put in for their studies, everything will be in a same evenly distributed data. Okay, A grade students or anything that is closely related data. Let's say you are working on luxury cars of India. See, all these cars are in that range, correct? So those type of data, you can take that normal average. That works best. But when you have outliers, okay, so this is very important. So you're calculating average for 2, 4, and 6. But let's say instead of 6, it is 6G. Okay, it is called this point. What we see here, this point is called as outlier, a completely off point. So when you have an outlier, what happens? Your average will also shifts. Okay, it will increase the average. Rest all points, let's say here, come here. So you are dealing with students, and the students like C grade students. Okay, the C grade students are like about 35 to 50. So you are dealing with students who have got from 35 marks to 50 marks. So in between, you have added one students who have got 99 marks. Okay, because of adding that marks, so your entire average will be shift. Okay, so it is does not suit for the data that has an outliers. It is well suited for a stable, evenly distributed data. We will see the mean calculation in an Excel in in a next video. So let's move on with the median mode. Okay, so what is mode? The most common outcome. Okay, it is well suited for data for like weather data. Okay, so if you see a weather data, a particular temperature may appear again and again. So 32, 32, 32. The minimum temperature may be 18, 18, 18. Okay, so whichever that occurs more frequently, most frequent data point is your representative point. Okay, we can't take an average for the data when it is having 32, 32, 32. Let's say 32 appeared 10 times. Okay, that is your representative value. Okay, so we don't need to take a simple average in this case. Okay, so the next one, median. So what is median? So median is very, very important. Okay, this is the true center of the data. it is the middle value. Okay, so median is the middle value when the data is arranged in an ascending or descending order. So if you have a data set, then you arrange the data set in an either ascending or descending order, and you take the center point. It's very important to understand right now why center point. Okay, so let's say the students marks, okay, 10 standard students results are out and you are trying to analyze the marks. So you have got like, sample of like 10,000 students from your city. And what you will do first, you will arrange the information ascending or descending order. Okay, so you arrange the information and try to plot an histogram. Okay, try to give a simple plot for that. And when you plot, right, you're gonna get something like this. We call this as a normal distribution of your data. Okay, not every time you're gonna get the perfect curve. Okay, but then let's assume that for now you got this perfect curve. So what is the representation of this data? So let's say one side you have score. Okay, one side number of students who have scored. So let's say your score is 35. Okay, number of students who have scored 35 is like 100 students. Okay, and this is 100, and this is 30, and let's say increase the score 50, and you will see again a quite lot of people, the increasal in number of students to let's say 500 students have scored 50, and let's increase it by 70. Okay, you will see again a little peak. Okay, that many students, around 20,000 students have scored 70 marks, 75. Then slowly it will decrease because not often every student can score 100 marks, correct? So again it will keep decreasing. So students who have scored 90, I see, because score here increases, right? So this point is 90, consider. So students who have scored 90 marks, maybe like 50 students or 10 students. So when you see the increasal in the data, I mean, when the score increases, the number of students will also decrease. Okay, so why it is so? Because in the real world, okay, any data that you plot, that the minimum points, the students who have scored, below 35 will be again, see, 25%. Not often you're going to see students who have failed. Again, no, very often you're going to see students who have scored very well, okay, exceptionally well students, or also very, very less, correct? Where is the cluster? Okay, this is where the data is clustered. Many students would score between 50 to 80. Okay, that is why we take the center point and we represent the entire data. Okay, why we are taking the center point? It is very important to know, because the data, when the data is having outliers. What is an outlier? Because 90 is an outlier, exceptional student. Again, people might have got 5 marks also. Okay, so when you have an irregular data, you can't find a simple average. And that is why you have to take the center value, and that represents the median, and that is the median, and that represents your entire data point. Okay, so this is about median. And quickly we will see these calculations in our Excel, okay, using your Excel formula, very simple formulas. Then we will understand much better. So see you guys in the next video.